All right, it's now a little after 8 o'clock on the 4th of January. The moon is probably in its 4th day. Did some eyepiece astronomy earlier with neighbors here at the Condo Association. We looked at the planets and we looked at the moon through a bino viewer, which came to focus, and it looked like it had about it could fully encapsulate the moon. So probably running somewhere around 50 to 60x. Had to use, of course, a Barlow lens in order to be able to come to focus through El Quattro, the 150p f4 Newtonian. What we're looking at right now is Messier 1. I spent about 45 minutes doing an alignment, and my principal issue is I've got a roof line to the west and I've got a roof line to the east and a palm tree to the west, which means picking out stars is very difficult from the point of view of doing an alignment. But just managed after 3 or 4 passes to get her done, and Messier 1 appears in a good part of the field. What we're going to be doing tonight is going over circumpolars. I already made a list of them. We will begin with NGC40, and I will add information on tomorrow. All I'm going to be able to do tonight is to go through a list of circumpolars that I basically grabbed online. The seeing is no better than it's ever been, maybe 3rd magnitude stars. I'm going to stand up right now and have a look at Orion. I can make out the sword, and the brightest star in the sword is magnitude 2.77, so maybe we're getting 3.5 skies. Can't tell you what NGC40 is, and even though we're exposing for 10 seconds and I've optimized the histogram, I'm not really telling what it might be. It's probably going to be a faintish open cluster. I'll have to figure it out later, but here's where M1 turned up, and that's our view. I'm going to go through them and add data on tomorrow. Well, you can see I'm just barely getting in on time on NGC48. It's a galaxy. It's probably around magnitude 15. It's part of a group with 49 and 51. We have the encroaching luminosity from the palm tree reflecting, and if I hadn't actually gotten in as quickly as I did, we would have lost it entirely, which it is one of my major goals for this evening. I believe this is like a 14.1 magnitude galaxy, so we would be very hard pressed to see it under these conditions. Let's go ahead to 49, but I'm going to allow that to continue to sit as I escape and do NGC 49. It's going to make a little bit of a hop here. Then I'll reinitialize the camera. We'll get an idea where it goes. View object. Okay, so it should have just made a little bit of a hop. The last one, 51, will be the brightest of the galaxies. Oh boy, I'm not pleased with this. Trying to eliminate that luminosity from this part of the screen. Let me go ahead and capture the name of this galaxy. What I hope we're seeing here right now is galaxy NGC49, part of a group with 48, 49, and 51. I'm not going to do a zoom in on this one. I'm going to do it on our next one because of the encroaching luminosity coming off the palm tree up in the upper right hand corner especially. Okay, I've already learned this is NGC 51, a galaxy. It's the brightest of the 3 galaxies. I believe 48, 49, and 51. They're in Andromeda. What I'm going to do now is do a zoom in because this is the brightest of them and should be potentially viewable by us. And as I've noted in the past, zooming actually improves the amount of light being captured because you're exposing more of the pixels in the CMOS detector to. I'm not really able to make out the galaxy anywhere here. We're at 70% now. It's about a 1.5 arc-minute size galaxy. Might be right there, so why don't I try, see what I can do with histogram settings. That'll give us any improvement in what we're seeing. So this concludes the 3 studies from the previous evening that I was not able to track down due to the proximity to the palm tree reflecting light. In fact, I actually moved the scope in order to be able to get it away from the palm tree, so we might have a half a chance of seeing NGC 48, 49, and 51. And frankly, I cannot make any declarations that we've done so due to the poor sky and the fact we have so much reflected light off the palm tree. Okay, I've had to skip over several because they were in the palm tree, so I'm not going to get a complete circumpolar on this occasion. I did get a rather late start. What we should be seeing here is, I skipped over 48, 49, and 51. What we should be seeing here is NGC 103. Not sure what it is, but down here it appears to be what I would consider to be a planetary, although it's not in the right position. There is a faint condensation of stars located right there. I'll go to 40%, 50% gain. I'll step through them, get to 100% where we'll be using all the pixels. There's no guarantee that anything that we're looking for will be on the screen. However, it is a nice exercise to step through them. Here's our 100% view. So that I presume that 100% view means we're using all 3008 by 3008 pixels. Each pixel is being given discrete opportunity to reveal what light it is seeing. 80, 70, 60, 50, 40, 30. 26 is as low as it returns to, and I cannot explain why it wouldn't return to 20% after going to 100%. Boggles me, but that's just the way they wrote the code. Okay, we're now tracking down NGC 110. Seems to be a bit of a void right here, and a star that could be a planetary right there. Once again, I am completely mystified. I have no other information available to me at this point other than the NGC reference number. So on the morrow, when I try to pull this video together, perhaps I will be able to better identify where on the screen. One thing we've recognized that has been truly accessible to us was right about this part of the screen where I'm pointing with the cursor. I have to remember I can do that. Why not zoom in on this a little bit, though? Not getting a sense of there being a central star, although there's red around it. I'm not sure why that's the case. Okay, we're at 110. I'm going to push it a little further this time. 170, 180, 200%. Wow, it just keeps climbing, doesn't it, folks? Look at that. Anyway, let's go back and see where we land in terms of zoom. Still 26%, at least it's consistent. Here we have the field. It hasn't quite integrated. We're still seeing some streaking, but yes. NGC 129 is likely to be an open cluster down in this Jeff, don't use your fingers. You don't have to do that anymore. You got a laptop here. Down in this region of the screen. We'll do a little bit of a zoom. I don't think I can get much beyond this given its position, if that is indeed a cluster. Back to 26%. There is our view of NGC 129, we hope. Our next study is NGC 133. no doubt an open cluster, but there's a possibility that either one of these may be a planetary nebula. And exploring we will go, 40%. I do believe this may actually be the cluster down there. So let's go ahead and back out, since we can no longer zoom in on it. Once again, that was, if that is the position, started to exit at about 50% of the field. Once again, we've returned to 28% zoom. All right, we should be now having a view of NGC136. Couldn't tell you what it is. Make your best shot. Probably open clusters. We are looking away from the core of the galaxy, and there tend to be a lot of off-axis open clusters to this part of the sky. This field of view is well peppered with tiny points of light. We are using the ST80 tonight. We are exposing for 10 seconds, which I think should press pretty close, somewhere between 9 and 12 inches in terms of effective aperture at the eyepiece. Here's our 50% view. Looks like there might be a double star here. Look at that. Backing out. Once again, 26%. Our next study is NGC146. Pretty clearly, there's a open cluster right in this region here, peppered with faint stars. I'd say they're probably all in the magnitude 10 to 12 range. Although I usually determine that by getting a sighting on the nearest brightest star, and this is probably about magnitude 7 there. And then I can create a pixel box out of that, basically covering that. Let's say it's 10 by 10 pixels. That means it's 100 times larger than the smallest pixels, which typically means it's 5 magnitudes brighter than the faintest stars that occupy a single pixel on the screen. So if that's let's say a 7th magnitude star, the faintest ones that occupy a single pixel are magnitude 12, but that single pixel could be very close to being fully flooded with light, which means you could probably drop down at least another 2 or 3 magnitudes in terms of the faintest visible points of light on the screen. Okay, Messier 31's distant Cassiopeian satellite galaxies are actually quite large, but not quite as large as Messier 110, which is about 16 arc minutes in its greatest presentation. These are like somewhere in the 8 to 10 and 12 with different aspect ratios. But you can see NGC147 right there on the screen, vaguely. Not the best presentation. As I mentioned in a previous video, when I first got started with this ZWO real-time stacking image production and visibility, I have seen this through a 3-inch scope, and it looked pretty much like that, but the conditions were much superior. Stars to magnitude 6 could be seen in the region because it happened to be on a rim of Crater Lake in Oregon with the 3-inch scope, which probably added about, I would say, at least 3 magnitudes to what I'm seeing now in the night sky. Let's have a look now as we zoom in on this study and see if it brings it out any better. It kind of does make it a little more obvious. Let's see what we have in terms of, now we're up to 40%, which I don't want to push it beyond because of a lack of focus on the part of the scope, which has very, very rough focusing capabilities that are best used with an eyepiece in real time. So that is our view of NGC147, a distant satellite galaxy of Messier 31, the Great Andromeda Galaxy, which is our neighbor in space and eventually will join the Milky Way in a cosmic marriage in about 3 billion years. As you can see, NGC185 is a slightly more condensed galaxy than NGC147. The core is more perceptible. There is some extension. It's slightly smaller. Both those galaxies are elliptical class 3s, which is basically based on morphological conditions. However, they both have huge deltas between the blue-violet and the visible light spectrum, which hints at the fact that there are very few massive early stage stars that are setting off some kind of stellar growth and evolution within the galaxies. Now, these are astonishing deltas between the blue-violet and the visual, something like 4 to 5 magnitudes, which is relatively unheard of. Not in galaxies we normally see hundreds of millions of light years away of the elliptical class. A typical delta between the blue-violet and the visual light is about 1.5 magnitude, however. We are getting a fairly decent view. The galaxy is well positioned on the screen. I am going to go ahead and do a little zoom in until the stars begin to offend us. And as you can see, it does apparently seem to get brighter as you do the zoom in, which is a phenomena that I would not expect in real-time imaging, and I cannot explain it at this point. So there's our look at NGC185. Both NGC147 and 185 were behind the palm trees, as you might expect. Both of those are the satellite galaxies of Messier 31, and I have imaged them previously. I'll probably at least include a snapshot from those images. We're looking at one NGC188, and I would say it's probably an open cluster right around here, fairly faint. You know, I could play a little bit with, maybe bring things out a little bit more. Yeah, that does help. I'm going to push the background sky. Yeah, more clearly an open cluster in that part of the screen, and that would be NGC188. So now we're going to push to NGC189. Here we have NGC189, undoubtedly an open cluster. Some star voids here, here, and here. The cluster could be located there. You never know. If I had a nebula filter on here on a good dark night, that we'd be picking up some reflective and possibly even emissive nebulosity, but that is not the case this evening. And I do want to point out that we may have missed a number of things because I should be spending some time with the histogram every time we move the scope to another position. Well, that's not too bad. Yeah, that brightened it up quite a bit. So I'll leave it right about there for the time being. There does appear to be something of interest there. I'm going to go ahead and do a zoom in. It's just a star with some spackling of infrared light around it. I suspect this imager is subject to infrared radiation and shows up as reddishness in the view. What we have here is our looking ahead view to NGC 225 because I wanted to cover some 15 or so studies between NGC 40 and NGC 189, which surprisingly, you know, the circumpolar studies from 45 degrees north and further north, it covers 90 degrees of sky, but it seems on average that there's only about 1 in 5 to 1 in 10 studies actually fall into the circumpolar parts of the sky. I'm really liking what we're seeing here on the screen now. This is some nice peppering of stars swinging around in a very inverse C shape, almost like NGC 6888, but made of stars rather than nebulosity. So there is our view. This will be the one we start off with next time. Hopefully we'll get a similar view should I get out in the next couple of weeks to continue this series. As an addendum to this, I thought I'd give you a look at Messier 42 and 43. View is actually quite good this evening. As I said, the sword stars are a little more present than they have been in the past. So here is our view. I can play with some of the settings here in terms of background brightness. We're starting to lose some of the emissive brightness to it as I move the cursor all the way over to the right on the histogram view. Gives it a nice dark background sky. Starts to speckle up, however. Now let's push this baby back over right to the peak. I wish there was kind of a line to show you where it's at. We'll also play with a little bit to get rid of some pixelation. That isn't ridding us of pixelation. We go here. Alright, pretty intense view of Messier 42 and 43. Gives us an idea of where we should have seen our earlier studies on the screen. Did a little zoom in there. As you can tell, we're starting to see pixelation. We're seeing some more extended nebulosity there. If I get off the top of the curve, pixelation. Well, obviously you can set this baby up just as though it were a sound system to give you the best possible view by playing with equalization patterns, this time in luminosity and not sound. Once again, carpe noctem, that will be it for this evening.